So for IQE7 porosity media, I wanted to do a faucet trickling down water into a sponge that is blocking the drain. I created this problem to understand the porosity, what effects the porosity of the sponge will have on the water. What impacts does the porosity have on the water trickling down to the drain? The porosity of the sponge adds friction over the drain, allowing the velocity of the water from the faucet to significantly slow down, which then allows the sponge to soak up the water. This creates the fluid flow to become super low, which implies that the flow is laminar. The flow near the solid boundary, the sponge, has a constant direction of flow. For my calculation question, I wrote all the knowns. So we know that the diameter of the faucet is 1 inch. We know that the water is trickling down. The sponge has a length of 3.5 inches, a width of 5 inches, and a porosity diameter of 0.005 inches. I converted all of that in feet. We know that the E for this is 0.85. I found the porosity through this website. Since it trickles down, so we can assume it's laminar, so we can use Darcy's law, which is friction equals 150 Vs mu times 1 minus E squared times length all over dP squared E cubed times density. And this is density of water, and this is mu of water. The length, as stated in the calculation question, is 14.25 inches, which can be calculated to 1.1825 feet. We are trying to find the velocity, the volume, the Reynolds number, and then the permeability. We can neglect EK, and we can neglect the change of the pressure drop through the sponge. The properties is the density of water, which is 62.3 pound mass per feet squared. The mu, or the viscosity, is 6.75 times 10 to the negative fourth pound mass feet per second, or times second. The first thing that we need to do is the Bernoulli equation from 1 to 2, which is labeled up here, 1, 2, which is P1 over density plus gravity times the height of 0.1. We can neglect V1 squared over 2, so the kinetic energy, because it's way less than V2. Then we can neglect P2 over density because of the change, the pressure drops. We can neglect Z2 because it's zeroed with no height the way I drew it. We can ignore kinetic energy, so we can ignore V2 squared over 2 plus the friction. The friction then equals gravity times the height of 1, which will get you 38.2375 feet squared per second squared. To find Vs, we can manipulate the friction, Darcy's law, to have Vs equal the opposite of friction, to incorporate friction. And when we put all the numbers in, it's 0.09418887 feet per second, which makes sense. The volume metric flow rate is Vs times the area projected, so 0.9481887 feet per second times 0.9167 feet times 0.4167 feet. And this is the length and the width of the sponge, to equal 0.0114475 feet cubed per second. For the Reynolds number, we know that it's density times the diameter of the porosity times Vs over 1 minus E mu. So plugging in all the numbers, we have the density, the porosity in feet, the velocity, the porosity. This is porosity diameter, by the way. To get 24.21992, unitless dimensions. And that's laminar because it is super low. K equals 3.16 darcies. And you can also find K with Vs mu L over density times friction to get 3.16 darcies. So they are equivalent to one another. And that is it.